So in this webinar, we're going to talk briefly about oracles, how they work and what functionality they provide. So recall that when we talked about contracts, that the contract code defines a pure function, and as such, it can't rely on or reference any sources of non-determinism at all. So the reason why this is the case is because all peers must have reached the same conclusion regarding whether a transaction is valid or not. If a transaction is valid at one time and then invalid at next, then the shared ledger would obviously lose its integrity. So we need to ensure that contract code always remains deterministic. Obviously, there might be a certain case or set of cases whereby it's necessarily to condition the validity of a transaction on some fact which is not on the ledger, either being true or false. So an example which I typically use is exercising an American call option, and that requires both the long and the short legs of the option to know what the price of the underlying instrument is that the option is over relative to the strike price of the option. Probably that price feed doesn't exist on the ledger, so we need a way to actually reference that price feed in a controlled way such that a snapshot of that price feed can be used in the verification of a transaction which involves exercising that American call option. So typically what you would do is you would reach out to an Oracle service that provides a digitally signed certified data structure over a particular fact. And an Oracle might provide digitally signed structures over many types of facts, or just one type, maybe just FX rates or interest rates or stock prices or whatever. But crucially, oracles are the window by which off-ledger data can be used on ledger by these deterministic or pure contracts. Another way for you to view an oracle is a source of data or calculations that the parties to a transaction have accepted as authoritative for a particular set of data. So let's say FX rates. The oracle can source its data in any way. It could receive the data from on-ledger data, perform some analytics, and then recycle that data back onto the ledger, or it could take the data from off-ledger sources. But I mean, crucially, it's exactly the same way that banks or financial services operate at the moment with data providers like Reuters or Bloomberg. They would provide data, this say FX feeds, and they would assure that this data is correct and up to date. And that's exactly what the oracle does. When you come to use an oracle in your transaction, it's available during the proposal, so the building of the transaction, and also the verification of a transaction as well. Typically, what would happen is you would write a flow that communicates with an oracle. You would ask the oracle to either attest over a fact that you have already inserted into the transaction, or you would ask the oracle to provide the fact and also sign over it or attest to it as well. Typical facts that an oracle could provide could be what's the OIS rate, what's the risk-free rate, what's the 10-year T-bill rate, holiday calendars for certain financial jurisdictions, and what's the current value of an option contract. Oracles can provide arbitrary off-ledger facts about pretty much anything. So there are a number of ways to implement oracles. The first one, and probably I imagine will be the most used one, will be using commands. If you recall, when I introduced commands in, I believe it was webinar 5, a command can contain arbitrary data. It just so happens that arbitrary data could be a signed data structure from an oracle. So what happens is when you need to include an off-ledger fact in the verification of your transaction, then you'd provide a command, say for example exercise, if you're exercising an American option, and inside that command there would be a placeholder for you to place or for you to collect the underlying instrument's current price from an oracle. Then what would happen is the oracle's public key would be added to that command, and for the oracle to become a required signer over that transaction. You can also use attachments as well. So for data that you would reuse, you could ask the oracle to provide it as an attachment. They would just provide an assigned data structure to you. Potentially it could be an Excel file or some other machine readable data structure. Then you can reuse this in a transaction over and over again. Typical thing might be a volatility surface to value some kind of complex derivative instrument. Typically you would use commands for regularly updating data or changing data, and you'd use attachments for large data structure that doesn't change regularly. As a recap, you can view oracles as an authority that attests to and may also provide off-ledger facts needed to verify transaction proposals. So attesting and also providing is pretty crucial to remember. So if you already have access to reference data infrastructure, say you work for a large bank and you have a lot of this data already available to you, then there's no need for you to use an Oracle to provide this data for you. But you do need to use an Oracle to sign over any data off-ledger data that you do provide in a transaction. And your flows or your workflow should reflect that. However, if you don't have access to that kind of infrastructure, then you can also ask the Oracle to provide that data for you, and presumably they would do for an additional fee. They'll provide the data as well as sign over it as well. So that's how oracles come in. The oracles operate as nodes on the Corda network and can be communicated with using flows just like any other node on the network.